Hey guys, so today is April the 7th, and I'm going to do another LeetCode Daily Challenge. I'm a little bit busy today, so I'm going to try to just grind this one out quickly. It's easy, so hopefully we could do it fast. Minimum number of operations to make elements in array distinct. You are given an integer array nums. You need to ensure that the elements in the array are distinct. To achieve this, you can perform the following operations any number of times. Remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all remaining elements. Note that an empty array is considered to have distinct elements. Return the minimum number of operations needed to make the elements in the array distinct. Um, so originally, if we have this is not distinct, right? I think I'm having trouble understanding what distinct means, but I think it means that there's a repeat, right? So if this is the original state, so far it's not distinct, so we have to move 3 elements from the beginning. So now we are dealt with this, right? And this is still not distinct. So we have to remove this, which means our new array is this and everything is distinct. Okay, so I guess we can do this by maybe keeping track of the frequency. Frequency is a default dict integer where the key is like the integer and the value is the frequency, like how many times that integer appears, right? So what we can do is just say for n in nums, frequency at n should go up by 1. And then I guess I could keep track of how many repeats, right? Number of repeats, 0. I'll put it down here. Just an initial count. So how should I do this? If frequency at n is greater than 1, then the number of repeats should go up. And then I guess while number repeats is greater than 0, that means there's a repeat that exists. Operations, right? We're going to remove the first 3. So I guess the index would start at 0. Frequency at nums at the index should go down 1. If that frequency is now 1, sorry, if this frequency that we just diminished is equal to 1, then the number of repeats should go down 1. And then we want to do this for I in range 3. Then or I guess I doesn't really matter. We'll just do that. And then we just have to make sure that our index bumps up every single time. At any point, we might run out of stuff. If index is greater than n is the length of the nums, greater than or equal to n, just return operations. After we do all of this, if number of repeats, this while loop will take care of that. All we have to do is just return operations. Let me go ahead and run this. I might be off by 1. Oh, I didn't update my operations. Operations plus equals to 1. That's the most important part, right? Oh, return operations plus 1. Okay. 3, 3. So it loops through these 3, and then our operations will now be 1. Then it loops through these 3, then our operations will be 2. Then how many repeats did we have? We had 1 repeat here. But we have 1 repeat that gets deleted. And then for this one, we still have 1 more repeat. And then it will get deleted, right? Print the frequency and the number of repeats. Time to debug this. 1 appears once, 2 appears twice, 3 appears 3 times, 4 appears once, 5 appears once, 7 appears once. And then 3 is the number of repeats. Is that true? 2. Oh, and then 3. If frequency is equal to 2, the number of repeats should go up. We're checking the number of unique repeats. There we go. Interesting. Okay. I failed to catch that. I didn't explain this good either. Anyways, I got this one wrong. Just like that? Oh wait, use the test case. Hmm. Oh, if we can't do the 3, so minus 1, minus... It might be minus 2, sorry, this is just annoying. It might be minus 3. If index greater than equal to n minus 3, return operations plus 1. Just do it outside of the for loop. If index plus 3 greater than or equal to n. Let me say it like this. Oh, it's just some bounds thing. If the index plus 3 is greater than or equal to n minus 1. Should be like something like this. Oh my god. If the index plus, wait, if the index is greater than n minus 3, or it might be greater than or equal to, something like this, right? N minus 4? I'm so confused. What? This is annoying. Whatever. I'll just do brute force and then finish. I'll come back to that. That's annoying. So brute force is, again, just have the frequency default ticked int for n in nums freq n plus equal to 1. We just remove it, and then we just do operations plus equal to 1, return operations, operations 0. If I greater than or equal to n, maybe I just do this. Actually, remove 3 starting at I, so we just do freq at nums at I minus equal to 1 if freq nums I is equal to 1. Repeat minus equal to 1, and then while repeats greater than 0. Return the operation. Oh, I didn't up the I. I needs to go up. Let's try that again. Okay, there we go. I think hopefully this works. I think it was I honestly think what I was doing wrong was this n thing. That was weird. Yeah, I don't know what changed. I think the only thing that changed is this n. Let me see, because this is annoying and I should learn from this. Maybe if I capitalize this, because I use n over here. I don't know if that matters. So I need to do that. This should work, right? Okay, so I guess this is a good lesson. Like things that like if you get wrong answers, you could trick yourself into thinking that it's a logical error. Like a logical error, which is the worst because in reality your logic is right. It's just you didn't do Python, or like in my case, I didn't follow the Python rules of renaming variables the same name. So yeah, I need to watch out for that. But this is almost like a counting problem, right? Like we keep the frequencies, and then whenever we get the number of repeats down to 0, or if we run out of index, then let's return our operation. So that's linear. yeah, it's just gonna be linear. Linear time, linear space. And yeah, hope you guys enjoyed the video. Sorry it's a little bit bad, but thanks for watching.